Oh, sorry. Is that better? Am I here? Okay, good. My name is Griffin, work for Graphics. Talk about the Scintilla TK porting project.
Brian, turn your mic on.
It is on. Is that better? I'll hold it closer. Okay. Before I go into Scintilla, first, quickie. We have a product called Model Sim or Quest to Sim. It's a HDL simulator and debugger. And in this the simulator, which simulates these various HDL languages, there's a debugger tool which has a source code viewer, and it can be used as an editor. That's primarily a viewer. Just like any debugger, it shows you the source code that you can single step through it, that sort of thing. The simulator uses Tickle for controlling the simulator, running it, and so on. And the GUI itself is all implemented in TK, Tickle TK, and a mix of C code as well. So we've had this performance problem in our source window, particularly. It does, one of the things it does, it's all implemented with a TK text widget, a lot of Tickle code around it. It does syntax highlighting of the source code, but as you can see in this loop that I'm running through, this is only a 1,500 line file, but if you jump down to the bottom of the file, it takes quite a while for the Lexer to get through and figure out how to color the text. And the flashing of the colors looks pretty bad. I don't know if you can make that out how the colors are flashing. So that was one performance problem that we've had for a long time. It's sort of just an annoyance. It's not a big major problem, but it's still an annoyance. We also added a feature in our text viewer to annotate the source lines with the actual values. So right under every variable that was referenced, every signal or whatever, we would display the value, the current value that the simulator has. This was really hard to implement just using straight Tickle and TK. What we ended up doing was placing labels on top of the text widget underneath. And we had to double space the code. I don't know if you can notice, there are places where there are no annotations, but it's still double spaced, so it's wasting space in the view. But as you scroll through the window, we have to lift all those labels up, scroll the text window, and then lay them all back down. So very annoying flashing going on. So we wanted to fix these performance problems, these annoying problems that we had. So we looked around at different approaches or ways to solve this, and we were looking at different text editors. We had some other performance problems with this board, I won't get into it, but looked at other text viewers around, and we really liked the characteristics that this Scintilla widget. Scintilla is it's a text widget. It's written specifically for source code displays, or just the sort of application that we have here. It's written in C++. It was first written for GTK and Windows, but it was also designed to have a platform isolation, so you could port it to other platforms, other rendering machinery. And it had a lot of nice features that we liked, and so we decided to try and port this to TK. Here's some of the features it has. So it has built-in lexers for a variety of languages, including the HDL languages that we use. It has, so it does the syntax highlighting. It does code folding. The widget itself handles line numbers. As you know, if you're using TK widgets, you want to display line numbers in your text, you have to add that you have to manage that yourself in your application. The Scintilla widget handles the line numbers directly. It has marks that you can put into a margin on the side, like for marking breakpoints or bookmark flags or whatever. It does inline annotations, just like we were trying to do. It's just built into the widget. indentation guides, all these other different features. And it is very quick. It was designed for speed right up front. It's already been ported to these various platforms. GTK and Windows 32 are the first ones, but all these others are already, ports for them already exist. And I think there's even more than this. These are the ones that I've uncovered so far. Another feature Scintilla has is so not only can you color code and specify different fonts, they also have these things called indicators. They're just different ways of highlighting. And these are just a small sample. There's actually 14 different indicators that it provides. Then the margin marks, so you can have 5 different margins, up to 5 different margins. Line numbers and folding are built in, but you can also have ones that have arbitrary text for symbols of various sorts. And then, of course, the annotations, they're inserted. I think they insert their annotations above the line. But they just create the space only where you put the annotations. You don't put an annotation on the line, it doesn't create the space for it. Very nicely done. Also, the annotations themselves are styled independently from the text, so you can color them, use different fonts, and so on. There's an example of Site is an editor application built around the Scintilla widget. And there's an example of the folding controls on the left there. And the indentation markers is also shown there. There's an example of inline annotations with different coloring and so on. So how do we get this into TK so we can use it? To port this, you have to provide to Scintilla these various things. So you have to provide a way to manage fonts, to allocate fonts and so on. Scintilla will request a particular font, a particular size, so on, and you have to provide the fonts for it, manage that resource. You have to define a surface. The Scintilla editor will draw on a surface, but you provide the surface. And you have to provide the base methods. Draw a rectangle, draw text, draw a polygon, draw a line, all that kind of stuff. Draw an image. There's also a window class for accessing things about the window size, scroll bars, things of that nature. They also have hooks for generating pop-up menus, list boxes, things like that. So you can do context-sensitive things within the editor. That aspect we completely ignore because TK does that more easily than we don't even need to use that in the TK world. Some kind of timer access. The language lectures are dynamically loadable, and so the platforms are responsible for providing the mechanism for loading a library and giving Scintilla access to the entry symbols. And then there's the generic platform, how you get the base, the desktop colors and double-click speeds, mouse speeds, and things like that. So here's an example. So it's the same movie loop that I ran earlier, but this is using the Scintilla widget. Notice it's got the line numbers, the folding markers. All the text is colored by the built-in lexer, and there's no flashing of colors, it just draws really quick.
How large a file was that?
Huh?
You said how large a file was that? That's not a problem in Scintilla because of TK.
This particular example is only 1,500 lines, but we've loaded megabyte, 100 megabyte files. And, we've tried even up to 300 megabytes, and it just snaps right wherever you want to go, scroll through. The load's really fast. So this is with the annotations turned on. When I made this, this particular movie, I noticed that there was a repaint issue, which you might see if you're paying close attention to it. I need to go back and talk to the developers working on this to figure out what that repaint issue is. But there's no flashing. All the annotations are drawn right in line. And places where there's no annotation, there's no space taken up, extra space. Move on. This is just showing the markers. So it's an example of single stepping through the code. It shows a little arrow where your current execution point is. That's an example of the margin showing the markers in there. Okay, so when we implemented this, we also decided to try and make it drop-in compatible with the TK text widget. So we started with the TK text widget subcommands for the widget. And this is a list of all the subcommands that the Scintilla widget supports. We've added some that cover specific features of Scintilla, and some we haven't implemented for various reasons. For the Scintilla specific set, annotation subcommands, how you add an annotation to the text, folds, how you manage, manipulate the fold feature. Keywords load Lexer. The way the Lexers work is kind of odd. You have to feed it this set of keywords. I can see where this makes a heck of a lot of good sense for Tickle. I'm not quite sure why you'd want to do it for C++. The keywords are pretty well defined. But in the case of Tickle, you can programmatically set the keywords for the language. And the Lexers can actually define multiple sets. You've got this 6 or 7 sets of keywords. And then I think each keyword set can have its own style and guideline. Load Lexer is how you load a shared library Lexer into the widget. Margin marker is all how you configure those aspects of the tool. Let's see. Oh, search, SCI search. So the Scintilla widget has a search capability, and the TK text widget has a search subcommand as well. And they were just enough different. There's a lot of similarity between them, just enough different that we figured people use the TK text widget search idioms. We implemented that so it matches the TK text widget search exactly. We also provide an SCI search if you want to use the specific features that the Scintilla widget search has. There's just some really subtle differences. I don't remember the specific details, but we just threw them both in there. These are the subcommands we haven't implemented. Most of these we'll get to eventually. If somebody wants to write them, it would be great. The image and window subcommands are not implementable because Scintilla doesn't have a notion of embedded windows or embedded images in the document. It's just text. The things that are left to do, it's not quite done yet. You have to complete all the various config options and subcommands. We haven't implemented event findings for tags yet. Oh, that was another. So Scintilla has a notion of styles. You can style text, and a style is color, foreground color, background color, font. It has no notion of tags at all. So you just define styles for the ranges of text. But tags are a very powerful feature beyond just styling of the text. It's used for a lot of other things, and we use it a lot in our tool for just marking important locations in the code. So we had to implement a whole tag subsystem in the widget so that you could use tags like you're used to using in the TK text widget. And that's, in a code count sense, it's probably a good half or more of the implementation of this whole widget. It's just managing of tags. So we have a tag mechanism. You can apply tags to any arbitrary ranges of text and use all the same tag commands that the TK text widget has. We haven't yet implemented bindings on tags. We haven't had a need specifically to do that in our particular application. But we should be able to do that at some point. I started writing, I took the TK text widget tests and took a subset of them and got some of them working. That really should be flushed out and completed in order to maintain some kind of compatibility between the TK text widget and the Scintilla text widget. There should be a generic method call on the widget to access, sort of a direct access to the Scintilla API. They have their API is sort of a message-based, kind of a Windows-like message-based API. So it should be easy to make it work as a straight direct call for that. The project has a configure script. It's been tested on one flavor of Linux and on Windows Mint-GW, and that's about it. But that really should be flushed out and tested for other platform support. And the documentation still needs to be completed. Things I'd like to see done with it in the future is, I think all the language lectures, right now we compile all the language lectures right into the widget, and we can just access them directly. But I think it would be better if all the language lectures were built as packages or modules that you could just package require and get the language lecture that you need. And then part of the package would be setting up all the keywords and the various coloring properties that you want. Right now, it's a bit complicated to use. There's in the porting effort implementation, there were two internal functions in TK or Tickle that we needed to use that are not in the public API. So for the dynamic library loading, you can use the load call that Tickle has to load a shared library. But we need access to the particular symbols that the Scintilla widget is looking for Alexa. And so we have to use the internal find symbol call. And then the other one is TK put image. Scintilla's interface, they don't have a notion of an image, an opaque image object. Not opaque as drawing, but opaque as not knowing what the data content is. So they don't talk about images in an opaque sense. They talk about it in an actual array of bits, which actually matches perfectly TK put image. And so they'll call back into the platform side to draw an image, and we just use that call directly. So what we've done currently is I've just copied that code out of Tickle and TK and put it into the Scintilla project for now. If they ever become public APIs, then we just call right into Tickle and TK to handle it. And then lastly, I think that the support should be moved right into the Scintilla project. They already manage GTK, Windows, Cocoa. I think there's one other. Which one? It's all maintained by the Scintilla project themselves. I think TK could fit right in. There is no code changes required on the Scintilla side. There was one code change, and that was a pound define, or I think it's a pound define in one of the header files. And they've already made that change in their code base. So there's no changes on the Scintilla side, so you can just pull latest Scintilla release, configure the TK side, and build the whole thing up. But you have to build the Scintilla code with the Scintilla TK code together. I hardly did any of the work. just a few bits and pieces here and there. These are the developers that worked on it part-time over the last year. The code has been, we've been blessed to give it to the open community. So it's already on SourceForge under Scintilla TK. And I've also put images on the flash drive for the conference, if you want to try it out. It's not complete, still a little buggy, but it basically works, and we'll be shipping in product at the end of this year. So, any questions?
You mentioned that you had the sources or something, but are they like publicly available somewhere?
Yeah, they're on SourceForge.
They're on SourceForge.
SourceForge, Scintilla TK.
License?
It's the BSD, I think, license. I think it's the same license that Scintilla has. Scintilla and Tickle.
Do you actually use it for any other languages in your development stuff?
In our internal development? Well, it's just in our tool just for HDL languages. So HDL, Verilog, System Verilog, System C, typical code, display our typical code.
Where'd you get a 300 meg source file?
Oh, that's small. We have.
Just kidding.
Just happy.
Okay.